Ever wondered if you could skip the traffic, forget the honking horns, wave goodbye to that annoyingly persistent tailgater, and just teleport to your destination? Now stretch that imagination to a cosmic scale. Welcome to a journey that's going to rocket us past the ordinary and the usual routes of time and space. Today, we're chatting about wormholes. Think cosmic shortcuts, not garden-dwelling creatures. These fascinating phenomena are like secret passages through space-time. Imagine being stuck in a cosmic traffic jam, surrounded by billions of stars and galaxies. You know, the usual Tuesday afternoon. But instead of waiting for light years to reach your destination, and let's face it, who has the patience for that? You sneak off on a detour, a cosmic cheat code. That's what a wormhole is. A hypothetical tunnel connecting two distant points in the universe. It's like your very own VIP lane in the cosmos. So, if you've ever daydreamed about teleporting the universe or had a chuckle over the mental gymnastics of bending space and time, you're in the right place. Fun fact, if wormholes exist, and that's a big if, we may just sneak past the light speed limit imposed by the universe. Buckle up, or rather, prepare to teleport, as we leapfrog into the wacky, wild world of wormholes and space-time. Do you recall the exhilaration of whizzing down a playground slide as a youngster? Picture space-time as that, but with more twists, turns, and a bit wobblier. Hold your horses before you start imagining yourself zooming down a cosmic slide. Let's take a breather to understand what we mean by space-time. It's like a four-dimensional tapestry, weaving together the three dimensions of space, length, breadth, and height, along with the dimension of time. But unlike the fabric of your favorite t-shirt, space-time isn't flat. Rather, think of it as a trampoline. Envision, if you can, a trampoline stretched out tight as a drum. If you were to place a marble on it, it would cause a gentle dip, wouldn't it? That's an easy-peasy way to envisage how space-time operates. The marble symbolizes a hefty object like a planet, and the dent it causes in the trampoline is what we call a gravitational well. The bulkier an item is, the deeper it plunges the gravitational well. Consider a bowling ball against a marble. The bowling ball will create a much deeper groove in our trampoline, just like how a burly object, like a star, warps space-time more than a less bulky object such as a planet. Now everything in the universe, from the tiniest speck to the most colossal galaxy, contorts space-time in this manner. And this contortion is what we perceive as gravity. And this is why we say that gravity isn't just a mysterious force yanking objects together, it's a curvature of space-time carved by mass. In essence, space-time is like a cosmic playground abound with these dents and wells. But it's not all lollipops and rainbows. These distortions can be astonishingly potent, bending light, making time take a breather, and potentially revealing cosmic shortcuts. Now, if space-time is like a grand cosmic playground, where do the wormholes come into play? Let's dive in. Do you remember that little known path you took to school to dodge the menacing neighborhood dog? Think of wormholes as the universe's version of such hidden shortcuts. Imagine running late for school, your usual route, blocked by a terrifying dog. The solution? Discover a quicker route. Now let's take this concept to a cosmic level. Instead of rushing to school, you're voyaging across the extensive universe, and instead of a menacing dog, you're up against billions of light years of emptiness. Enter wormholes. Wormholes, theoretically, are the universe's clandestine corridors, the cosmic equivalent of hidden alleyways. Despite the name, they aren't actual worms, but conduits in the fabric of space-time. They resemble those clandestine passages in ancient mansions often featured in mystery books, but they are far more elusive and infinitely more complicated. Shockingly, if we liken the universe to a sheet paper with your current location at one end and your destination at the other, the swiftest route isn't to journey across the surface but to fold the paper so that each end meets. That's fundamentally what a wormhole does. It folds space-time, creating a direct route between two distant points. I bet you didn't know that. It's almost like having an extremely fast secret cosmic railroad that avoids the standard routes. However, hold off on packing your bags. We're still not completely certain that they exist. They're a conjecture of Einstein's theory of general relativity, and we've yet to spot one in the wild. Even more surprising is that if we did find one, we're unsure of how to keep it open. Wormholes have a tendency to collapse, which would be equivalent to your shortcut to school vanishing, leaving you directly in front of the menacing dog. So wormholes could are clandestine pathways through the universe. But have you ever wondered what it would be like to travel through one? Ever been through a car wash? Now imagine that, but it's a cosmic car wash, and you are the car. Journeying a wormhole might sound like a thrilling space adventure, but let's not forget, it's not exactly a jaunt around the park. Instead, here's a fun scenario for you. Picture yourself as a cosmic surfer, riding the waves of space-time on a roller coaster ride with whirlwind speeds, blinding lights, and the odd sensation of the universe bending around you like a pipeline wave. Exciting? Absolutely. Terrifying? Quite possibly. You see, a wormhole is a tunnel with two ends, each in separate points in space-time. Much like a water slide at a space-themed amusement park. But instead of ending up in a pool, you end up in another point in the universe. On Earth, we're used to 3 dimensions: length, width, and height. But in a wormhole, we'd be dealing with a 4th dimension, time. That's like trying to play chess on a triple-decker chessboard while riding a unicycle on a high wire. It's a whole new level of complexity. And then there's the small matter of surviving the trip. Wormholes, theoretically, are volatile and unstable. They're like cosmic sandcastles, impressive to look at, but prone to collapse at the slightest disturbance. A single photon could potentially destabilize it. So you'd not only need to be a brave cosmic surfer, but also a master of timing to make it through. But let's assume you've made it past these hurdles. What would the trip be like? Well, imagine going through a cosmic spaghetti machine while simultaneously being stretched like a rubber band. Not exactly your everyday experience, is it? And as for time, it could either speed up, slow down, or both. You might emerge on the other side, only to find that while you've aged a mere few minutes, centuries have passed in the outside universe. Talk about a time travel hangover. So, wormhole travel might not be as easy as hopping on a cosmic surfboard, but could we ever create or find a stable wormhole? Well, that's a question for another scene. Stay tuned. Ever tried finding a needle in a haystack? Now, imagine the haystack is the entire universe, and the needle is a wormhole. Piece of cake, huh? Let's dive into the immense, mind-boggling difficulties of this cosmic game of hide-and-seek. The first challenge is simply finding a wormhole. The universe is a pretty gigantic place. And when I say gigantic, I mean it's like trying to find your car keys in a house with 1,000 rooms, and you can't remember which room you left them in. Then there's the issue of stability. Wormholes, according to current theories, are quite unstable. They're like cosmic squirrels on a caffeine high, darting about, popping up, and vanishing faster than your favorite TV show that got cancelled too soon. They're about as steady as a 3-legged chair. Definitely not what you want to trust your morning commute or your life to. And let's not forget about the energy required to keep a wormhole open. We're not talking about a few Energizer bunnies here. We're talking about negative energy. Yes, you heard that right, negative energy. That's something we're still scratching our heads over, let alone have it stored in our backyard. Oh, and did I mention the exotic matter? To keep a wormhole stable, we would need something called exotic matter. And no, that's not a fancy name for a rare type of chocolate truffle. It's a type of matter that, theoretically, has negative mass. That's right, negative mass. It's as elusive as a polite internet troll, and we're not even sure exists. But hey, we humans are a stubborn lot. We've climbed the highest mountains, explored the deepest oceans, and even left our footprints on the moon. Who's to say we won't one day discover or even DIY a stable wormhole? So while we might not be zipping through a wormhole for our daily commute anytime soon, rest assured the universe is brimming with possibilities waiting to be discovered. Or lost again. So we've dived into the depths of wormholes and emerged on the other side, or have we? In the vast cosmic playground, wormholes are the elusive slides, fascinating yet unseen. Theoretical tunnels in the fabric of space-time, they promise shortcuts across cosmic distances. Imagine that, reaching your favorite star system, bypassing the pesky light years. But there's no free cosmic lunch. We've also explored the challenges, the need for exotic matter, the threat of instabilities, and the small issue of actually finding a wormhole. It's like hunting for a needle in a cosmic haystack. We've through the theoretical, the tantalizing, the wondrous, and the challenging, all from the comfort of our armchairs. The question remains, will we ever get to ride a wormhole? Until we find out, here's some food for thought. Even if we can't find a wormhole, at least we're not stuck in traffic on the Milky Way.